Okay, so this is the EC310 12-week exam from spring AY 2024. So this is mostly signals and a little tiny bit of networking stuff, hoping to help you study for the 12-week or the final exam. So first, starting off with question number 1 here. This is a networking problem. We're looking at a layer 2 topology showing a connection with Hopper Hall. Students in each room connect to a fast Ethernet at 100 megabits per second, right? So we're going to need that number for the first question here. We've got each device connected with 100 megabits per second fast Ethernet. What are the apparent bit rates for the following users? So mid and 1 is right here, and their domain is going to be everything connected in here, including that bridge, right? The hub is effectively just not there. We can pretend it doesn't exist. It's just a connection through to the bridge there. And so we've got 1, 2, 3, 4 devices because we include the bridge as one of those. And so we've got 100 divided by 4 is 25 megabits per second for that user. We're going to do the same thing for mid and 4. For the second question, they are connected to the switch, and the rule for switches is it's 100 divided by 2. It's just the user and the switch that are on that. So that's 50 Mbps. So that's it for the first one. Next up, given a 75 megabyte file, how many Ethernet frames would be required to send all file data? Assume this includes all overhead added by layers 3 through 5. So we're assuming that's got all the packet and segment and message stuff. So we're looking at this diagram for this question and seeing that it has, at max, we can send 1500 bytes per frame, right? So this is the Ethernet frame format, the layer 2 format. So how many of these 100 or 1500 byte frames do we need? We've got 75 megabytes, which is 10 to the 6th over 1500 per frame. And that's going to give us 50,000 frames in total. So that's it for that one, just understanding that this is the max amount of data we can send and dividing that number. On to part C. So below we have a frame, and we have, we're trying to find out who's it going to, who is it coming from. So we're going to use this format below to decode this. And really the important thing is we need to know that 1 byte is 2 hex. All right, so every 2 hex value, hex digits that we see there, which B and C are both hex digits, that's a byte. So then we're going to look through and find 6 of those. So 1, 2, 3, 4, 5, 6, and that's our destination. And then the next 1, 2, 3, 4, 5, 6 is our source. So then after that would be our length or type, right? Those 2 bytes. And then our data comes afterwards, and then at the end we can assume that these are our CRC. So just to sort of push the rest of it through there for your understanding and studying. Then for this question, we're looking for the destination and source IP addresses in our diagram at the top. So we've got BC, or our source is 47C1. Let's see where we've got a 47C1 is midshipman 2. So destination midden is 2 there. Just matching this address to the address up at the top, right there. And then destination BC07, let's see, that still matches 94. BC0794 is midden 4 for our store, or for our, I flipped these. These should be reversed, sorry. So that should be 2 is the source and 4 is the destination, but hopefully you get the idea. And then last part, what is a role of layer 2 data link layer nodes? I think on the solution it says point to point flow control. You could also say error correction, or error detection. We have the detection. Sorry, writing. Error detection, we have the CRC there, that's what that's for. We could also say multiple access. There are a lot of potential answers, those are a couple of them. So that's it for the first question.